Okay, so here we go. Today, the first thing I want you to do is find this file. It was posted for today's date, which is December 12th. Sorry, December 2nd. And it is lesson 8.3. It's about exponential equations and basically using what we've learned about logs to be able to solve exponential equations. Now, today's is actually so easy. We only have a couple, like one main kind of problem to learn how to solve that I have kind of taken today as a review day. So I'm going to review some stuff with you, and then I'm going to have a quiz that I'm going to have the sub handout in my next hour class, and they're going to be sitting right on the table up front here. They're called the Chapter 8 quiz, logs and exponentials. That little quiz is going to count in the homework category for you, and the key is also sitting up here, so the sub will be able to have a student read off the answers off the key so that the kids can have it graded in class at the end of the hour. Okay, so that's what we're going to do here too, is this little quiz is coming. It's only going to count in homework, so don't stress about it. But the review I do with you right now is going to help you get ready for that. Yes? No calcs. No calcs on any of the quizzes or on today's homework on anything. No calcs. Because you can just graph both sides and see where they cross, and it answers almost everything. Do you get how powerful that is to know then? On the ACT, for instance, where they do allow calculators all the time. I'm not saying you can answer every single thing in the world with that, but a lot of pre-calc can be answered by graphing both sides and seeing where they cross. Okay, so here is a little bit of review for you. The very first thing that I taught you was how to rewrite things into a log. Would you please, right now, add some room in the homework that you just found there, today's homework, and add some room to do a little bit of practice. Rewrite that as a log. Do you get that logs and exponentials are very closely related? What does it mean that you can rewrite from one to the other? Well, those things are not just related, they're called inverses. Okay? And if I were to graph log, would you make a little sketch, please, of what log looks like? Just a simple one like log base 2. What does the log look like? I've told you that it looks kind of like a tree being blown over in the wind because that's what a log is, right? Okay, for the answer for this one, you should have said log base 5 of 24 equals x. That is rewriting a log out of an exponential. Do you get that both of these, when you solve them, would give you the same decimal? And think about it for a moment. The decimal is not, let me think, 5 to the second would be 25, but it's really close to that, right? So it's really close to 5 to the second, but a little bit less. So do you get the answers about 1.9-ish? Okay. So, but this equation, if I graph both sides, so where they cross, it'd give you about 1.9. This one, if I put it in the calculator right, it would tell me about 1.9. Do you remember how to put that in the calculator? We'll write that down next. What would you type to put that into the calculator? Did you say log 24 over log 5? I'm aware that some of you have Nito calculators that can do things directly, but the way I could have asked this that would have forced you to write it that way is I could have said, write this as a base 10. Do you get it goes into the calculator because it's in base 10? All right. Now, one last stretch on that. What if I said, this is in base 5 now. Write it in base 7. Once you've changed it to base 10, it's really easy because it's a fraction. And one of the weird principles of this is that if I change this base, I can change it to anything I want. I could say log base 7. And it'll come out the same. Why? Because by making this base a little smaller than base 10, then both numbers just got smaller. And since it's a ratio, this one divided by that one, if both numbers got smaller and you divide them, if they both got the same amount smaller, then you're going to keep the same ratio. So you can have any base you want. So there it is in base 7. Not going to type it in the calculator that way, because calculator doesn't do base 7. But this way is common. What's the other base that, oops, sorry. What's the other base that's real common besides base 10? Base E. That's also known as what? ln. Whenever you see ln, one of the things I've reminded you is that you should, whenever you see ln, write it as log base E. Okay. A little bit ago, I asked you to sketch what a log looked like. Have you got that done yet? All right. Here's what a log looks like, generally. Now, how tight that turn is depends on how big the base is. So if I was graphing y equals log base 20 of x, it'd been much sharper turn than that. But the bigger the base, the sharper the turn. Okay. So this one's probably more just like 2. Or what's that base that's actually a letter, but it's actually a number? E. And E is about 2.7. Do you get how that's pretty close to 2? And I usually have you round E to about 3. Okay. It'll still look kind of like that. So what's this domain and range? Domain 0 to infinity, and then the other one? All reals. Negative infinity, positive infinity. Goes forever this way and this way. Okay. That was the log graph. What's the exponential graph? Remember exponential growth? It kind of looks like that. And do you get that these are kind of related to each other? What did I say a second ago? They were whats of each other? Inverses of each other. Okay. So then that means they are a reflection across the line equals x. Line y equals x. They're a reflection over that line. So they are inverses of each other. So the domain of the one is the range of the other. We learned about inverses before. Okay. Another thing you learned about logs is a bunch of properties like log base 5 of 125. If I make the bases the same, then good things happen. Okay, in this case, what should that 125 turn into? 5 to the 3rd. If that becomes 5 to the 3rd, then all of a sudden the bases are the same and the answer is already there. It's 3. Okay, another property is if I make this a 1. That's the argument position, and so I just won the argument. What do I get? 0. What are some rules about these things? You know a whole bunch of things about logs. Tell me some stuff about the base and the argument. How about stuff it can't be? Can't be 0. Can't be less than 0. The base cannot be 1. This one can be 1, but that one can't be 1. Okay. How about expanding them? Do you remember expanding them? Log base 3 of xy. Expand that one. Usually they'll say, write this as 2 logs. Instead of just having 1 log, you'll have 2 logs. I don't want to tell you too much like 2 logs that are being added, because that'll give you too much information. But in this case, it is. It's log base 3 of x plus log base 3 of y. And you just change this multiply into a plus. All right. Can it get more complicated? Of course it can. Let's say that's a y to the 3rd. Then there'd be a y to the 3rd right there. And then where should we put it? In front. That's called the power rule. That anything that's got a little power on its argument, the power can come down in front of it like that. We're going to use all these principles, all these little rules, in complicated problems. So you have to know them, like, oh yeah, if it's log base 3 of x squared, of course I can just put the 2 right there. That's got to be like second nature for you to be able to use those little rules like that. Okay. So there's also condensing. What if I start with 3 log base 2 of x, and then I add 5 log base 2 of 2. Pack it all down, condense it all down into 1 log. Is that what? I'll tell you the answer in a second. Pack this all down into one log. If I answer that, it'll be telling you how to do it, and I don't want to do that because you should have enough info to be able to do it. Just wait till I give the answer, and then see if your question still pertains, still applies. All right, so I'm going to pack this all down. That's going to go up here. That's going to go up here. And I'm going to have log base 2 of x to the third plus log base 2 of 2 to the fifth. Now, I know some of you might be thinking, but Mr. Server, that could have equaled 1, and therefore 5 times 1 could have equaled 5. But then, if it was just a 5, if all of this was just a 5, I couldn't put it together with this one. I couldn't pack it all down into one log. So I'm going to finish it up here. Now I can put these guys together and say log base 2, that's added to that. So then this has to be times that. Now I could put this as a 32 or a 2 to the fifth. I would have accepted either. It's better to say 32. No, it's not, actually. It's not really any better at all. It's just 2 to the fifth would have been fine right there. And usually you put the number in front of the variable. So I'll put it like that. But I'd have been fine with you saying 2 to the fifth. Do you still have a question, or are we good? Okay. Yes? That is a different thing. We never say condense and simplify, but we do say expand and simplify. So like that's this kind of problem where you started with something small and you simplify it. So like you're making it bigger, and then you notice that something can turn into a 1. Like let's say this had been a 3 right here. Then you would have wanted to make this into a 1 times 3. You do simplify, but it's never condense and simplify. It's always expand and simplify. Okay? All right. So if you did expand one out and you got this, no, plus, you got it all expanded out and it looked like that, you should not leave it like that because there's something you could do. If it's expand, it's always expand and simplify. So what should I do now? Yeah, this becomes 5. I'd say 5 plus log base 2 of x. I know that seems strange because the goal was to expand it, and this makes it smaller, but the directions are expand and simplify. So wherever you can, if you ever get something like this that's like, oh, that's just a number, then simplify it. Okay, so here's what's going to happen next. In a moment, you're going to clear off your desk, not yet. You're going to clear off your desks, and you're going to take this little quiz, and I have some thoughts on that. I have a time limit on it. It is a 10-minute quiz and 10 questions. Because some people could obsess over this thing for 25 minutes because there's a tough question on here, and they probably still wouldn't know how to do it. I am giving it a time limit. 10 minutes, 10 questions. You got to be done when the 10 minutes is up. Okay, so clear off your desks. Stuff something to write with. After that, there is more to this video. So I'm going to just hit pause here, and then I'm going to teach you the new stuff. After the quiz is done, we're going to unpause it, and you're going to be able to hear the rest of the lesson for today. All right, pausing now. Okay, I'm going to read over these answers quick. Number 1 is log base 3 of 10 equals x. And if the kid forgot the equals x, they'd lose a half a point. Number 2 was exponent. I would accept exponential or exponent. If they say anything about exponent in their answer, they can have half credit, but a log is an exponent. That's the only thing that gets full credit. If it's blathering on about something about exponents, give them half. Number 3 was the inverse of the log. Inverse of a log is an exponential or an exponent. It's supposed to be exponential, but I'll accept the word exponent. Number 4, it's just 0. That's the only right answer. Number 5, this part was 5 because the base was e, and then the bases are the same. So anyway, 2 to the 5th is a good answer. or 32 was a good answer. Number 6, this one had a 1 in the base. You can't have that, so no solution, or you can write out no solution or undefined. Number 7, it's log base 2 of x to the third and y to the fifth. And number 8 is if they have this written out as log base 10 of 100 and didn't simplify it, then they would lose a half. They should have simplified it to 2. So the final best answer was 2 plus log y to the negative a half, or even better, put that negative a half down in front, and you have 2 minus 1/2 log y. That's the best answer for number 8. Okay, number 9, what is the domain and range? The domain was 0 to infinity, and the range was all reals or negative infinity to positive infinity. And the last question, number 10, was 2. All right, so you'll get a score on the top on this one out of 10. And yeah, there we go. Now I'm going to get you into the new stuff. So everybody, please get out today's lesson and find this page on it right here. I think it's the second page. It's on under today's date, which is 12-2. Okay, for today's, I really only have to teach you one major topic, and that's how to solve equations using some of these principles of logs. So this kind is solved one of two different ways. You can either make the bases the same by saying the 4 could really be 2 squared. X equals 2 to the 3x plus 3x minus 1, sorry. I just made the bases the same. Why is that good? Because since these are both 2's, then these powers must be equal. So I know that 2x must equal 3x minus 1. 2x. The 2's down here are disappearing. That and that are disappearing. 2x equals 3x minus 1. And then I can just solve that. That'll be easy. Subtract 2x from both sides. 0 equals x minus 1. Add 1 to both sides. 1 equals x, or x equals 1. How do I know that works for sure? Well, I put in a 1 right here and a 1 right here. I'll end up with 4 to the 1 is 4 equals 2 to the second, and 2 to the second is 4. So yeah, 1 works. All right, I did that by making the bases the same. But there's another way. And there needs to be, because on problems like number 2 here, do you see why you can't just always say, well, I'll just always make the bases the same? Do you get how that 5 can't be made into 2 to the something? At least not easily. 2 to the really something really weird. All right, so I need a new strategy. All right, I'm just not going to use this problem to show you that. I'm going to show you the new strategy to solve that one again. I know the answer is 1. I already got that. But here's how you'd solve it with the other strategy. It lists it right here. Take the natural log of both sides and use the power rule. Now, I disagree with this a little bit. Do you remember me telling you yesterday you could do log on both sides? But I like to do the log strategically and not just take the natural log. You can. It works. But do you get that I could take the log of with any base on both sides? Like right now, since I didn't say a base, what log did I just do on both sides? Log base 10. Okay. But it'd be probably smarter if I chose log base what? Log base 2 would work, but 2 would work really well, I think. But I was using log base 4 last hour because I wanted this and this to be the same. Then I'd have to do log base 4. But I think 2 would be even better. Do you see why? Yeah, this log base 2 here would make this whole thing into like 3x minus 1, because the answer is the exponent then, right? So that would come out to 3x minus 1. There's no log anymore. And this one, I could change this 4 into a 2 squared. See what I mean? All right, so you can do the log on both sides, and that solves these problems. I'm going to ask you right now to do the log base 2 on both sides and solve it that way. Log base 2. It's probably the most interesting way to do it. So the original problem said 4 to the x equals 2 to the 3x minus 1. And I'm going to do log base 2 on both sides. Just work that one through and see what you get. I'll pause for a moment while you try that. Okay, so some thoughts. That one simplifies to just 3x minus 1, because if the bases are the same, the answer is the exponent. Green on green, probably not a great idea. Let's try this. 3x minus 1 is the right side. The left side of the equation was this. Did anybody think of something smart to do? Yeah, the 4 could be 2 squared. So you'd say log base 2 of 2 squared to the power of x, or 2 to the 2x. Why was that smart? Because now this whole side turns into 2x. You see why? Base is the same. So now 2x equals 3x minus 1. Now that's the same exact equation we got before, a lot quicker, by just setting the bases the same. You see how setting the bases the same, if you can, is a pretty good way to go. All right, so here's another one where you could set the bases the same. 2 to the 5x is equal to 32 to the x minus 4. Everybody try to set those bases equal to each other. Don't try to use logs. Just set the bases equal. I replaced the 32 with a 2 to the 5th. That's all I really did, is right there. This 32 became this 2 to the 5th. And now that the bases are the same, this has to equal that. Notice it's not 5x minus 4. It'd be 5x minus 20. 5x equals 5x minus 20, or 5 times the quantity x minus 4. Now this one's getting weird, because then when I solve it, 0 equals negative 20. Whenever you get a false statement like that, do you remember what that means? No solution. There is no way to make this work. This has no possible solution. You've got to be prepared for stuff like that in pre-calc. Happens a lot where we have answers that are no solution, or we even get answers that are not really working, and they're called extraneous solutions. All right, here's one more where it'll actually work out nice. Let's use 3 as a different, so you can see it doesn't always have to be 2's. 3 to the x equals, well, let's just keep it simple. 27. No, wait, that one's way too simple. Sorry. That's just 3 to the 3rd is 27. Okay, so let's make it, I want to pause for a second while I get this right. Okay, I had a suggestion that I make this 3 to the 2x and this to the x minus 6. And I am, let me think. That will work. That one will work. Yep. Okay, try solving that one. All right, so some thoughts? Now I made the bases the same. So 2x, this part, has to equal this part, should equal 3x minus 18, or 3 times x minus 6. And then I'm going to subtract 2x from both sides. 0 equals x minus 18. Add 18 to both sides. 18 equals x. X equals 18. If I wanted to be sure I was right, I go back to the original, stick in an 18 right here. And 3 to the power of, ooh, that's big, 36, apparently equals 27 to the 12th. Whew. But here, 3 to the 36 is supposed to equal 27 to the 12th. I can fix this by going 27 is really 3 to the 3rd, right? And then that means 3 to the 36th. So it does work. Okay. All right. So that's the stuff for today. And there's a 12-minute warning. So get you into your homework now. Everybody find the first page of your homework, which is right there. It says day 1 on it. And tomorrow or Monday, we'll use the same document, do day 2 of it. Okay. Notice, same base. They can both have a base 2, right? Same base. They can both have a base 3. Where's the one where it doesn't work anymore? That one. 3 and 5. They can't have the same base easily anyways. And therefore, you need a new strategy. Do you remember what we did? Take the log of both sides. You can take log of any base you want. What base might be smart to use? Log base 3. Or you could rewrite this. Remember me saying anytime things get tricky, you can often rewrite them? I could rewrite that as a log. Log base 3. Jump to the other side of 5. Anyway, I'll let you finish it from there. All right. So those 6 problems are all assigned. And this one, I want to just remind you quick that it's a fraction, and I've trained you to get rid of fractions. You always go through and multiply by the denominators, and that'll fix it. You won't have fractions anymore. But I want to warn you also that you're going to get to the end, and it's going to be like this. E to the x equals, let's say, 12. And you're like, how am I supposed to solve it? Whenever you get stuck, think about a rewrite. Do you get how this one could just be rewritten? Log base what? E. See? Log base E of 12 would equal x. And x is alone, so even if you don't know what this equals, as long as the x is alone, you have solved it. So that first one's going to be kind of like that. All right, this one and this one, I'm going to let you skip those. I want to make the assignment reasonably sized for you. And on number 8, I do want you to do A and B. Again, these can sometimes be challenging, but rise to the level of the problem and do it. Number 9, skip. I want to give you challenges, but I want to give you so many that you give up and it takes you forever to finish your homework. So, all right, I think that's a happy medium on how much to assign you. And that's all I got for today. The rest of the time is you working on your homework.